Okay, here's part 3 and the conclusion of this combination reaction. So we're going to go through the questions and one by one, and I'm going to show you what the end product looks like. So question 1, what's the color and appearance of the iodine? Okay, this is the iodine crystal. I'm going to see if we can get a little closer. It's slightly purplish in color, and it is a little sparkly. And that's what it looks like before. And when we put it into the alcohol for after dissolving, it looks kind of like this coloration right here. It's kind of a yellowish orange. So that's what iodine looks like before and after. So iodine is a purple and sparkly, I like that word, sparkly solid. And becomes, and if you remember from the video, it becomes, when you put it into the liquid, that was the alcohol, it becomes a reddish, orange, yellow, it's hard to determine what color that is. Becomes, we'll just say a yellow, orangish color. Becomes yellow, orange when dissolved. So iodine is purpley and sparkly. It's a purple and sparkly solid, just like it is right here, and it becomes this yellow, red, orange material when dissolved. So when adding the iodine to the ethanol, the crystal dissolves, which causes the color change. This is not a chemical reaction. What is happening to the iodine? Some things, when they dissolve, they just have a different color. There's a material when you're in chemistry, it's going to start off as a green crystal, and when you put it into water, it turns blue. So some things just look a different color when they're dissolved. So dissolving just changes the color. Dissolving changes the color. That's the simple explanation for that. Next part, if the iodine is in the yellow solution, what is the significance when the yellow liquid becomes clear after swirling? If you remember, after we paused and came back, part 2 of the video shows lots of zinc, and it's kind of grayish in color, but the yellow is gone. It's completely absent. What does it mean, though, if there's no more yellow? So we started off with this dissolved iodine with this yellow-orange, and then it goes away. So what must that say about the presence of this iodine when there's no more red, orange, yellow coloration? Well, if the yellow is gone, that can mean only one thing. If the yellow, red, orange is gone, what that means is, well, that was the iodine. That means the iodine must be gone as well. Well, it didn't disappear, it didn't dissolve. There was the actual chemical reaction which sort of sucked it up into the new compound. So if the yellow, red is gone, the iodine must be all used up. So let me show you the product. This is what it ends up looking like. Okay, let me show it to you over this dark. What it is it's this white powder. This is the new compound that formed. So what's interesting is that we start off with the zinc, and we start off with this iodine, and we end up with a completely different looking substance here. And this is the white solid that forms at the end. How is the product different from the reactants in appearance? So the product, this is the ending stuff, the product is white. And the reactants, this is to review reactants and product. Reactants is your starting stuff, product is your ending stuff. So the product is white, and the reactants are purple and gray. The iodine was the purple. So here's the iodine. We'll go ahead and we'll put the iodine here, which is I2. And the gray is the zinc. What evidence is there that shows a chemical reaction has taken place? Well, this is very different, this white powder, compared to this gray and the silver. That's our evidence. The products look, or product in this case, the product or products look or looks different than the reactants. So I'd like to share with you guys the chemical reaction that is taking place. We are taking zinc. Again, here's the zinc powder. And we're taking the iodine, zinc and iodine. These are my reactants, and it produces this white powdery stuff. This white powdery stuff is zinc iodide. No balancing is necessary for this. We have one zinc here, we have one zinc, we have two iodines, we have two iodines. This is the combination reaction. This is why it's called the combination reaction again, is because you're taking these two things and they combine together to produce a single thing.